So I'm going to walk through 3 examples here of completing the square. Okay, so there's a lot on this screen, but let's take it one piece at a time, and through multiple problems you'll start to see how this works. So we start with our trinomial here, and what our first step is to get a and b by itself, right? So we want to move this 19 over. Okay, when we do that, negative 5 minus 19 is negative 24. Now our next job is we want to make this a squared and this ax squared and this bx, we want to add a c so that this whole thing is a perfect square. The way we do that is we take b, we take half of it and we square that. And that's just because of how perfect square trinomials work. And we went over that in class. So if we take b, which is negative 11, take half of it is negative 5.5. Negative 5.5 squared is 30.25, which is this value here, which is what we add on this side. If we add one thing to the left side of the equal sign, we also have to add it to the right side of the equal sign. So that keeps it balanced. That brings us down to this spot here, right? We can take this perfect square trinomial and collapse it down into x minus 5.5 squared. If you don't trust me there, you could expand this out into x minus 5.5 times x minus 5.5. And if you FOILed that out, you would get back to that equation. So again, the whole reason we add this c term is so we make a perfect square trinomial that condenses down into this little burrito type thing, right, where we only have an x, and it's a perfect square. Perfect square meaning if we expand this out, we get back here. Anyway, now we're going to solve for x, so we can take the square root of the left side, that gets rid of that square, and we're left with x minus 5.5. But we also have to take the square root of the right side. So to solve for x, we want to bring this 5.5 over by adding it on both sides, and we're left with this. Now this plus and minus here is really important, because anytime you take a square root, there's a positive square and a negative square, right? 1.5, actually no, 2.5 is the square root of 6.25. Negative 2.5 times negative 2.5 will get you 6.25, as will positive 2.5 and positive 2.5 will get you 6.25. That's why there's a negative and positive root. Now if we take 5.5 and add that square root, we get 8. If we subtract, we get 3. That's why there are 2 roots, and these are our solution. I'm actually going to pause there and split this up into separate videos. I'm going over on time.